Hello dear students, good afternoon.
Good afternoon, sir.
Welcome back to the chemistry class again. In the last class, we are discussing about the rules for assigning the name to an organic compound. Selection of parent child, assigning the number, right? So within that, you have two or more possibilities. Select the parent child, which gives maximum branch. Assign the number in such a way that according to lowest set of locant and sum root. Lowest sum root, lowest set of locant root. Now, just add few more rules to the same for branched alkenes. Next rule number. Rule number 3. Yes. Next. While adding the prefix to the root word. So we have discussed regarding the name of an organic compound which contain prefix plus. Yes. Root word plus primary and secondary suffix. So this is the general format. Now in this, regarding the root word, it is clear. Root word, that is number of carbon atoms present in the parent chain. That is selection of longest chain, parent chain. So it is over. And after that, we have assigned the number. If any substituent groups which are used as a prefix. So we have determined or we have find a root word, primary suffix, secondary suffix, and prefix. Then how we are going to arrange those? First prefix and root word, primary suffix, secondary suffix. So while adding the prefix to the root word, its number is also mentioned. At which position the prefix is there, that number also you need to mention. For example, if this is the compound, one organic compound, so somewhere I have mentioned the substituent. So a root word, how many carbons are there?
5.
Pent, 5 carbon atoms. Numbering, how we are doing the sum? Right to left or left to right?
Right to left.
Yes. Number 1, 2, 3, 4, 5. So 5 carbon atoms, root word is pent. Plus primary suffix. Primary suffix. Ale. Confirm? Yes, primary suffix is ale. Secondary suffix. No functional groups, therefore no secondary suffix. Any prefix? One prefix is present. Which group are they? Methyl group. So methyl. So while adding this prefix methyl to the parent child, we need to mention its position also. So methyl group is present at 2. 2 methyl. 2 methyl. So this number and alphabets are separated by hyphen. Always a number and alphabet is separated by hyphen. If two numbers are there, like 2, 2 dimethyl, if one more group is there, 2, 2 dimethyl. So 2, 2 numbers are separated by commas. Number and alphabets are separated by hyphen. So there is no space between prefix and root word. It is a continuous word. While adding the primary suffix, it is directly added primary suffix. While adding secondary suffix to this primary suffix, the last letter E is removed. If this letter, this next secondary suffix, if it starts with an consonant, last letter E is removed if it is an vowel. If it is retained, if it is a consonant. I will give the examples, we'll come to know that. So this is the some other rules. So few more points we can add. So after the next rule number 3. Next rule. While adding the prefix to the root word, continue. While adding the prefix to the root word, its position is mentioned before it. While adding the prefix to the root word, while adding the prefix to the root word, its position is mentioned before it. Its position is mentioned before it. Next rule, this point. Next rule. A number and alphabets are separated by hyphen. Next rule. The number and alphabet. The number and alphabet are separated by hyphen. The number and alphabets are separated by a hyphen. Next point. If more than one similar substituent groups are present, then we are using the numerical prefixes. See, you have used 2, 2 dimethyls. Why dimethyl? If suppose an organic compounds in this is CH3 group and this is C2H5 group. What is the name? How we are going to send? Okay, 1, 2, 3. 3 ethyl, 3 methyl. Correct? Suppose if this is also CH3, 3, 3 dimethyl. So if more than one similar groups are present, then numerical prefixes you are using. Di means 2 methyl groups are there in the whole compound. 2, 3. Suppose here one more CH3 group is there. 3, 3, 5. Trimethyl. So the numerical prefixes you are using, and before that you are mentioning its positions. So this rule already have written. So one more rule: if more than one same alkyl groups are present, or same prefixes, same substituents are present, more than one same substituents are present, come on, then numerical prefixes such as di, tri, tetra, etc. are used. Di, tri, tetra, etc. are used. Numerical prefixes. Special point. While deciding the alphabetical order, because you know that some alphabetical order you are deciding. While deciding the alphabetical order, note that while deciding the alphabetical order, so these words di, tri, tetra, numerical prefixes. So these words are not considered in open chain. While deciding the alphabetical order, in the next line, write down di, tri, tetra, etc. That is, numerical prefixes are not considered. In bracket, not considered. Alphabetical order, you D, T, T, you will have to consider dimethyl. Which letter you need to consider? M only. Diethyl, only E. This starting letter D is not considered in open chain. In bracket, note down. In complex substituent, these are considered. In bracket, write down. In complex group, it is considered. In complex group, it is considered. Next, second point. If the compound is secondary, tertiary are not considered. Secondary butyl, tertiary groups, if it is mentioned, then these are not considered while deciding the alphabetical order. Whereas iso, neo, cyclo, etc. these are considered. The letter I, N, C. Alphabetical order. While deciding the alphabetical order, these are considered. Secondary, tertiary, not considered. Di, tri, tetra, these are not considered in open chain. Whereas if it is a branched complex groups, then it is considered. Or yes. Next, let us name few of the compound. Write the IUPAC name of the following compounds. Along with the example, few specific rules I will indicate. First one, write the IUPAC name of. Write the IUPAC name of the following compounds. Write the IUPAC name of the following compounds. Yes. What is the IUPAC name of this compound? Main question, write the IUPAC name for the following compounds. Number one, first example, I have given a compound. What is the IUPAC name? First, write the answers in your notebook. Take the question and write the answer. First point, first rule, select the parent chain. Longest chain select, which contains maximum longest chain, that means carbon carbon continuous chain. Second step, assign the numbering. So one, after selecting the parent chain and assigning the number, it is easy to assign the name. Select the parent chain, assign the number. Yes, what is the name? Complete. Yes, yeah, complete answer.
4 ethyl, 2,5 triethyl, so trimethyl pentane.
Innocent check for small mistake. Almost correct. Small mistake. 4 ethyl.
2,5 triethyl
Trimethyl heptane. Pentyl heptane, correct? Parent chain 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. Maximum 7 carbon. Correct? So this is a parent chain. So this is the parent chain. 1, 2, 3, 4, 5, 6, 7. So root word is hept. Primary suffix a. Secondary suffix annular. Secondary suffix is not there. Prefix 1, 2, 3, 4 prefixes are there. Substituent groups. So second step, assign the numbering. Numbering is given from this end. 1, 2, 3, 4, 5. So at second position, 2, 2 methyl groups. This is methyl group Me, methyl group Me, methyl group Et, methyl group. Methyl. 3 methyl groups are there. What are the position? 2, 2, 5. 2, 2, 5. How many methyl groups? Yes, try methyl groups. One ethyl group is present at which position? Fourth position. Ethyl group is present. Or yes, arrange the first, add the prefix. So if 2 or more prefixes are there, then according to alphabetical order, E comes first and then M. So T is not considered. Correct? Yes. So E comes first. Therefore, the name is 4. Number and alphabet are separated by hyphen. 4 ethyl. No space. Continue word. 4 ethyl. Next. 2, 5. Numbers are separated by commas. Number and alphabets are separated by hyphens. 2, 5. Trimethyl. No space. Continue word. Root word. Heptane. No space. Single word. Yellow space illa. From this to continue. Only one word. 4 ethyl. 2, 5. Trimethyl heptane. Correct? Yes. Next, second example. Next example. Now we are also already with the. Yes, boys, fast product. Second example. Good. Very big. First, very big. Write the answer in your notebook first. Or stand up. Here.
2,4 methyl.
You miss again. Something is 2, 4 trimethyl pentane, right? Yes. Parent chain 1, 2, 3, 4. 1, 2, 3. So 2, 4 trimethyl pentane. Good. Next example. Yes, what is the name? Good. Continue. Pentane. Because 5 carbon atoms in the parent chain. Parent chain 1, 2, 3, 4, 5. You can select. ಯಾವ ತರ notes say over. So numbering. So yeah, suppose if I selected from this 1, 2, 3, 4, 5. So and you can select any chain, only 2 substitute. So therefore select any one. So 1, 2, 3, 4, 5. At 3 position, 2 substituent groups are there, that is ethyl. So name 2, 2 diethyl. Yes. 3, 3 diethyl pentane. Good. Then what is the APPA name of this compound? 2, 2 dimethyl propane. Correct? 2, 2 dimethyl propane. Yes, right. Next example. Yes, right. Correct. Is mistake idರಲ್ಲಿ? Next example. Next example. What is the name? ಅರ್ಥ ಆಯ್ತಾ? ಈಗ ಯಾರು ಹೇಳ್ತೀರಿ ಅಂತ why you are laughing? Answer 3 ethyl 2, 3, 4 trimethyl exit. Biology shape answer ನಮ್ಮ chemistry biology ಗೊತ್ತಿಲ್ಲ. Right. Take one more example with complex group, some different group. So what is the name of this simple compound? If the substituent group is a complex, then how we are going to assign the name? If a substituent group is complex, then we are assigning the name. Yes. Again, say select the parent child. Select the parent child, assign the number. Which substituent group is there? Secondary group. 1, 2, 3, 4, 5. Yes, okay. Group what is pending. Substituent group. And I think it is at third position. No? It is at 3. Secondary group. Total number of carbon is 1, 2, 3 tetramethyl. Tertiary butyl group. Tertiary butyl, but APPA name. So while a special point, you can note it. While assigning the name to a substituent group, if it is complex, note if the substituent group is complex, then again same rules used for this compound. Leave this. Totally parent and bit between. Now, what is the name of this compound? IUPAC name? What is the IUPAC name of this group? 2, 2 dimethyl. Yes, correct. 2, 2 dimethyl. Propane, correct? So its name. This is same compound. 2, 2 dimethyl propane, right? So since it is a substituent, that propane becomes propyl. So in bracket, you need to write this at third position in bracket. So its name 2, 2 dimethyl propyl. Neo? 5 carbon atoms is there, means it is spent. It is only 4 carbons. So this carbon is not considered. It is parent chain. Substituent is only 4. So its IUPAC name, always you need to start from this carbon atom. So it is 1. But here it is 2, 2 is wrong. 2, 2 is wrong. Propyl group is also becomes wrong. Reason only. So if the substituent group is a branch chain, then substituent is a parent chain. To the parent chain, some substituent groups are attached. Substituent group model 1, 2, 3, some carbon atoms. Some substituent groups are there. Any branch chain substituent is complex. Then always you need to start selecting the parent chain from this carbon atom. It is the number 1 always. Substituent group complex there, you need to start the numbering for this carbon atoms and select the parent chain. So 1, 2, 3, 4, 1, 2, 3, 4. So if you are selecting this as a parent chain, again one substituent. So I am selecting this as a parent chain. 1, 2, 3, 4. So it is butane. Correct? Only for this. Write the name for this compound first. So it is butane, okay. 2 ethyl, 3 methyl butane, right? Since this is a substituent, so therefore it is butyl in bracket. At which position? Somewhere, some positions. Fourth position. 4 in bracket 2 ethyl 3 methyl butyl. So similarly, so for this is the first carbon, it is second carbon. So 1, 1 dimethyl ethyl. So this must be 1, 1 at third position. 1, 1 dimethyl ethyl. At first position, methyl group is possible or not? In open chain. At first position, methyl group cannot be present. Yes, what is your doubt?
Sir, that carbon should be considered for above.
It is in the parent chain. Yes. To this carbon is linked.
Now,
Yes, 1, 2, 1, 2, 1, 2. So 2 carbon in the parent chain to substituent. So 1 comma 1 dimethyl ethane. Since it is a substituent, it becomes ethyl. Now write the IUPAC name. First write the structure and then assign the IUPAC name. I will give some wrong names. You need to write the structure for that and then assign. Okay. 2-ethyl propane. Write the structure for 2-ethyl propane. It is a wrong one. Write the structure for 2-ethyl propane and write the correct IUPAC name for this structure. 2-ethyl propane. First write the structure. 2-ethyl propane. It is wrong one. Now, what is the correct IUPAC name for that structure that you have already written for that? 2-methyl butane, correct? What is it? 2-ethyl propane. So that means 3 carbon atoms, 2-ethyl. So for that, what IUPAC name? So 1, 2, 3, 4. So 2-methyl butane is the correct IUPAC name. 2-position ethyl group cannot be present at 2 position because if it is there, it is considered in the parent chain. Second position like ethyl glycerol, it always present in the parent chain because second position ethyl means again those 2 carbon, it must be taken in the parent chain, not substituted. Maybe present at 3 positions. Next example. 2,2 diethyl butane. What is the correct IUPAC name for 2,2 diethyl butane? Diethyl butane. It is the wrong one. So write the correct IUPAC name for 2,2 diethyl butane.
3-ethyl pentane.
So
2,2 diethyl butane. So 1, 2, 3, 4, 5, 6. Hexane. 2,2 diethyl butane I have given you. So this is the structure 1, 2, 3, 4. Butane, 2 position ethyl. 2,2 na? Yes, 2,2. 2, 2 diethyl. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 pentane. 3 position. 3-ethyl, 3-methyl pentane is the correct name. 3-ethyl, 3-methyl pentane is the correct name. Next. This one. Yes, root node 1, 2, 3, 4, 5. Pentane. 3 in bracket 1, 1 dimethyl ethyl pentane. Pentane. First write the answer in your notebook and then yes, 2 groups are there. A special point here. If 2 or more complex substituents are there, then the numerical prefixes bis, tris, tetrakis, pentakis, etc. are used. If more than 2 substituent groups are complex, then bis for 2 groups, tris, tetrakis, only one S, not 2. Pentakis, etc. are used. Tetra, penta, etc. If more than 2 substituent groups are complex, in that case, since here 2 substituent groups are complex, bis in bracket write its name along with the positions. Numbering 1, 2, 3, 4, 5, 6, 7, 8, 9. Root word Root word non-end, right? Non-end over. Then prefixes. Two prefixes are there at position 4 and 5. So 4 comma 5. Since same group 4 comma 5. This in bracket. 1 comma 1. Ethyl. 1 comma 1. Ethyl. Okay. Yes, non-A. Yes, please. Means more than two substituent groups are complex. If it is complex, then bis plus etc. are used. If it is normal, then di, tri, tetra, penta, etc. If it is complex, bis plus etc. are used. Yes, this is one more point you can note. This is in case of branched alkanes. Branched alkanes. Next, number 2. For compound containing multiple bonds. Yes, 4. These rules are repeated. Next, second one, APPA rules for the compound containing multiple bonds. Compound containing multiple bonds. Yes, again here also the same rules, but small variations. Number 1, first rule. Select the parent chain which contains. Select the parent chain which contains carbon-carbon multiple bonds. Select the parent chain which contains carbon-carbon multiple bonds, which may or may not be the longest. For example, select the parent chain. Six or 7? 6. 1, 2, 3, 4, 5, 6, 7. But if double bond, triple bond, or any functional group, if it is present, the first preference you need to give for the functional groups, and second for multiple bonds. That must be present in the parent chain, even though it may or may not be the longest. So, including this double bond, we need to select. So, therefore, number 1, 2, 3, 4, 5, 6, 4, 5, 6. Everybody same version, select any one of the parent. So, this is the parent chain. And second, numbering. So, here also same numbering is given in such a way that the doubly bonded or triply bonded, multiple bonded carbon should get least number. Instead of substituent, first point, select the parent chain which must contain multiple bonds, carbon-carbon multiple bonds, even though it may not be the longest. Alkanes is compulsory longest relay, but if in case of multiple bonds or functional groups considered which may or may not be the longest, but the functional group containing carbon must be present in the parent chain. For example, madhve hoಗ್ತಾರೆ ಮದುವೆ ಗಂಡು तो ಮದುವೆ ಹೆಣ್ಣನ್ನು ಬಿಟ್ಟು ಹೋಗಕ್ಕೆ ಆಗುತ್ತಾ ನೀವು ಮಾಡ್ಕೊಳ್ತೀರಿ ಇಲ್ಲ ಅಂದ್ರೆ ಮತ್ತೆ ನೋಡಬೇಕಂದ್ರೆ. So that is the first priority we are going to give for those two. First functional group ಕೊಡಬೇಕು, ಅದಾದ multiple bonds, and then rest is next. So first priority. So since carbon compound it containing double bond, this is the special functional group. It must be present in the parent chain. It may or may not be the long. Relatives ಬರ್ತಾರಲ್ಲ ಸೆಕೆಂಡ್ ನಿಮ್ಮ ಪೇರೆಂಟ್ಸ್ ಅಂತೂ ಬರಲೇಬೇಕಾ ಇಲ್ಲ ಪೇರೆಂಟ್ಸ್ ಬಿಟ್ಟು ರಿಲೇಟಿವ್ಸ್ ಬೇಕಂತ ನಡೀತಾ ಇಲ್ಲ. ಫಸ್ಟ್ ಪ್ರಿಯಾರಿಟಿ ಪೇರೆಂಟ್ಸ್ ಕೊಡು, ಅದಾದ ನಂತರ ರಿಲೇಟಿವ್ಸ್, ಅದಾದ್ಮೇಲೆ ಮತ್ತೆ ದೂರದ ರಿಲೇಟಿವ್ಸ್, ನೆಕ್ಸ್ಟ್ ಫ್ರೆಂಡ್ಸ್. So first priority, the doubly bonded carbon or multiple bonded carbon must be present in the parent chain. It may or may not be the longest. First one. Number two, assign the numbering in such a way that the multiple bonded carbon should get least number. Suppose here one substituted groups are there. Substituted group. If substituted group is present in this position, the numbering is given from this end or this one. From this, because first priority multiple bonded carbon should get least number. So number 1, 2, 3, 4, 5, 6. In. Now root word. Root word. X. Root word X. The primary suffix is in. At which position? First position. If it is first position, you may or may not. It is not necessary. It is not compulsory. But best way is in. At which position? First. X 1 in. This is the correct. Or this can be written as complete other substituent groups are there. Just I am saying the root word. X 1 in is the correct way of writing the APPA number. Or simply you can write hexene, hexene 1 or 1 hexene, etc. You can write. Substituent groups 3 propyl, 1 methyl. Sorry, 5 methyl. So which how we are going to arrange? P and M. M and O. First M come first. So 5 methyl. Yes, 5 methyl. 3 propyl, hex 1 E, hex 1 complete. If multiple bonds are present. Suppose, what is the name of this compound? Root word, first step, root word. How many carbons? 4. But. Primary suffix. Ena, ina, aina. In. Yes, sir. How many double bonds? 2. That means die. What are the positions? 1, 3. Starting number 1. It started at first. Second. Again, second one is started at 3. So, but 1, 3. Die. Or this can simply we can write 1, 3, 1, 3 butadiene, butadiene, or butadiene 1, 3. But the best way is this. This is the correct APPA command. But 1, 3 diene, diene. If 2 double bonds are there. Suppose if a compound containing 1 double bond and 1 triple bond, 1 double bond and 1 triple bond. Priority goes to double bond among these two. If it is at equivalent position, eradu same position is there. Higher priority goes for alkenes. Sorry, alkenes. Yes. So numbering 1, 2, 3, 4, 5. Suppose again, if it is triple bond and this is double bond, then numbering how we are. Numbering is given from this end 1, 2, 3, 4, 5. See that simple rule. The multiple bonded carbon atom should get least number. First point. Suppose if both double bond and triple bond are the equivalent position, then priority goes to alkenes. But in this case, if you are assigning the number from this end, it is at second position, but alkynes at first position. So first least number numbering is made from this end. If at equivalent position, priority goes to alkenes. Note on these two examples. And then write 2 more points. Points for first point, okay. For rules, first select the parent chain which contains carbon-carbon multiple bonds. Second point, the numbering, assign the numbering in such a way that carbon containing multiple bonds get lowest number. Assign the number in such a way that carbon containing multiple bonds should get least number. Next, if more than one multiple bond is present, then how we are going to use more than one multiple bond? The numerical prefixes we are using. More than one multiple bonds are present, use the numerical prefixes di, tri, tetra, etc. But these alphabets are not considered while deciding the alphabetical order. Next, third one, if more than one multiple bonds are present, use the numerical prefixes di, tri, tetra, etc. Next point, very important. If both double bond and triple bond present at the equivalent position, double bond and triple bond present at the equivalent position, double bond and triple bond present at the equivalent position, come on. Higher priority is given to double bond. Higher priority is given to double bond. Yes, read out these two examples. 1, 2, 3. Three examples. Write its IPAC name. First IPAC name is over. Yes. Yes. Then how we are going to assign? Both are there. In and ein. So root word in this case, pent. Root word is pent. Primary suffix ina, aina. So first priority you are giving for in. So at position 1 in, last letter E is replaced, 1 in 4 ein. 1 in 4 ein. This is the IPAC model. Next, for this, again pent. Your answer is wrong. 4 in 1 ein. While writing the name, ein, triple bond is always written at the end, last. Ein. Even though the priority order goes for all keys. In ein, in ein, in ein, in ein. 4 in, the last letter is replaced by ein, 1 ein. So always the multiple bonds you need to mention along with its position where it is present. Even prefixes also. How the position to mention market. Complete on? Complete? Yes, on this concept, solve the number of examples. Write the IUPAC name for the given compounds. For alkanes, branched alkanes containing multiple bonds. In the next class, we'll discuss the IUPAC nomenclature of the organic compound containing functional groups. Functional groups ಬರ್ತಕ್ಕಂಥ discuss ಮಾಡೋಣ. So tomorrow we'll